Lesson 11.1 is on inverse variation. In this video, you will learn to use and identify inverse variations, as well as graph inverse variations. Okay, vocabulary, inverse variation, and product rule. Okay, so what is an inverse variation? Well, if you remember, earlier in the year, we learned about direct variation, where we said that y equals kx. And we said basically it's going to be like a line that goes through the point 0, 0, where k is like the slope. And we said, okay, if x is this, when y is this, what is k, right? And we solved for k by putting in x and y. Now we're learning about inverse variation, which the formula is y equals k over x. So this one, it was times x. Now we're going to be looking at what the function looks like when it's divided by x. And we're going to see that these graphs look something like this later on, but we'll get to that. Okay, so we want to be able to identify if something is direct or inverse variation. So we want to see if these numbers work and we get the same number for k for y equals kx, or y equals k over x. Okay, so looking at these, if I put in x, 6 for x and 3 for y, I'm going to get 3 equals k times 6. And solving for k, I'm going to divide both sides by 6, so 3 over 6 is 1/2. Okay, so I want to know if I take half, if my equation is y equals 1/2 x, does that work for the rest of my points? So if I put in 8 for x, do I get 4 for y? I do, because 8 times 1/2 is 4. So it works for this one, it works for this one, and it should work for this one as well. So half of 10 is 5, so it works. Okay, if we had plugged into this one first, we would have put in the 3 for y, and then I would have solved for k by multiplying both sides by 6. So I would have gotten k equals 18. So we would see that 18 over x doesn't work for each of these. So if I did 18 divided by 8, it's not equal to 4. Or if I did 18 divided by 10, it's not equal to 5. So we know it's not going to be this one. In this case, it's this one, which was of the form y equals kx, and that is for direct variation. Okay. So I want to do the same thing with this. I want to see if it works for y equals kx, and I also want to see if it works for y equals, I don't know why I keep doing that, y equals k over x. Okay, so plugging into the first one, I'm going to put in 1 for x, so I'm going to have k times 1, and 12 for y, so I'm going to get 12 equals k. And I want to know if that works for each of them. So if I do 12, so if this was the equation y equals 12x, putting in 12 for k, does it work for this? If I do 2 times 12, do I get 6? No. So it's not, I know it's not going to be inverse variation, sorry, direct variation, but I want to check and see if it's going to be inverse. So I'm going to put in 12 for y and 1 for x, and I get k is 12. So I want to know if y equals 12 over x works for each of these. So if I do put in 2 for x, 12 over 2 is 6, so it works. If I put in 3, 12 over 3 is 4, so it works. So in this case, this is going to be inverse variation. Okay. We want to also be able to look at an equation and determine if it's direct or inverse variation. So before we had the two equations y equals kx and y equals k over x. So I want to look at these and see which way this looks more like. So both of these have y by itself. So if I want to just get y by itself, if I have negative 2xy equals 20, to get y by itself, I'm going to divide both sides by 2x, negative 2x. So here, this is going to cancel, and my x's are going to cancel, and I get y. And here, 20 over negative 2 is going to be negative 10, and we still have x in the bottom. And because the x is in the denominator here, this is going to be more like that one. So this is going to be inverse variation. Okay, So looking at this one, if I want to get y by itself, what I'm going to do is divide both sides by 0.5, which is the same thing as multiplying both sides by 2. So if I multiply both sides by 2, I get 2x equals y. And this one is going to be direct variation because the x is now in the numerator. So this is direct variation. Okay, assume that y varies inversely as x. So this is the clue when it says it varies inversely that we want to start with y equals k over x. Okay, so then they say if y equals 5 and x equals 3, we want to write an equation that relates x and y. So I'm going to put in 5 for y and 3 for x, and I want to solve for k. So the first step is always going to be find k. So to do this, I'm going to multiply both sides by 3, and I get 15 equals k. Once I have k, I am not done. This is not my solution. The part says write an equation that relates x and y, which means I have to have x and y. So I want to use this just filling in what my k is. So I want to say y equals 15 over x, and now that is my final solution. Okay, we want to learn the product rule for inverse variations, which says that if you have 2 points, then the solutions of an inverse, so if you have 2 points that are solutions, then the products x1 times y1 and x2 times y2 are equal. Okay, so that would be this first one here. We can say they're equal. Or we can do the ratio of x1 over x2 is equal to y2 over y1. Notice that switch there. Okay, so if it's hard to remember that that switches, it might be easier just to do 1 point times the other and then do it like that. Okay, so let's do a practice problem with this so you can see what it looks like. So it says, assume that y varies inversely as x. If y equals 5 when x equals 12, find x when y equals 15. So we want to look at this and we want to come up with our 2 points, x1, y1, and x2, y2. Okay, so now the first two that are listed are x1 and x1 and y1. So y1 is going to be 5 and x1 is going to be 12. So we have the point 12, 5. That means our second point, we don't know what x2 is yet, but we know our y is 15. And we want to be able to solve for x2. So we said that x1 times y1 is equal to x2 times y2. So I'm just going to do 12 times 5 is equal to, x2 is what we're looking for, times 15. So 12 times 5 is 60, and that's equal to 15x2. So to solve for x2, I'm going to divide both sides by 15, and I get 60 over 15 is 4. So I get x2 is 4. So this is one way to solve for that x. And then they said the other equation is the x1 over x2 equals y2 over y1. So if we were to use this one, our x1 is 12, our x2 is what we're looking for, y2 is 15, and y1 is 5. So if we were to solve this, 15 over 5 is 3, so I'm going to get 12 over x2 equals 3. And then I can multiply both sides by x2, so I get 12 equals 3x2, and divide both sides by 3, and I get x2 equals 4. So you get the same answer. So whichever way you like better, either as the fractions or as the products, either way works. Okay, when two people are balanced on a seesaw, their distance from the center of the seesaw are inversely proportional to their weights. How far should a 105-pound person sit from the center of the seesaw to balance a 63-pound person sitting 3.5 feet from the center? So again, we want to use this with those points. So I can say 105 pounds. We don't know the distance that that person is sitting, so we're going to call that x. Okay, and then the other one is 63 pounds, and they're 5 feet away. Okay, so we want to solve for x. So we can remember we can do this times this. Our first point, it's x and y coordinates together. So I'm going to get 105x if I do that. And then I'm going to do 63 times 3.5. And when I do that, I get 220.5. Then to solve for x, I'm going to divide both sides by 105. I don't know what I wrote there. Okay. And so I'm going to get x is 220.5 divided by 105, and we get 2.1. So the 105 person should sit 2.1 feet away from the center of the seesaw. Okay. Okay, we want to be able to graph an inverse variation in which y equals 1 when x equals 4. So we want to come up with our equation. So I'm going to have y equals k over x. Okay, so it's k over x because it's an inverse variation. So if y is 1 and x is 4, that means my k is going to be 4. So really my equation is going to be y equals 4 over x. And I want to make a table of values to represent this. Okay, so if I put in some values, say I put in 1. 4 over 1 is 4. So I'm going to have the point 1, 4. Okay, if I were to put in negative 1, 4 over negative 1 is negative 4. So I'm going to put in the point negative 1, negative 4. If I put in 2, 4 divided by 2 is 2. So I have the point 2, 2. If I were to put in negative 2, I would get negative 2 because 4 divided by negative 2 is negative 2. So it would be that point there. If I were to put in 4, 4 over 4 is 1. If I were to put in negative 4, I would get negative 1. So I have the point 4, 1, and negative 4, negative 1. So I can see that this is kind of the shape that it's taking. We can put in a little bit more points to be a little bit more exact, but for now we're just going to stick with this. So this is going to be more or less the shape of my graph. An inverse variation function is always going to have this kind of two-piece looking type graph. Okay? So which of those is the graph of this one? Okay. So just a review of the different variations that we've learned. We learned direct variation, which we said is a line, and then inverse variation is this two-piece kind of curvy line thing. Okay? And that's the end of lesson 11.1.